Hi, Assalamu alaikum. I hope you are fine and doing well in your organic classes. Today's topic is about organometallic, which is a separate area of organic chemistry, in which we focus on organometallic compounds that possess carbon and metal connectivity. These organometallic compounds are quite important with reference to organic synthesis, which is chiefly dependent on this area because different organic molecules are synthesized with the aid of these organometallics. So, in our today's lecture we are going to address what are organometallics compound, how can we distinguish them or we can identify them, what are its important feature. We will also talk about some usual organometallic compounds such as organolithium, organomagnesium. We will also focus on organosodium compound, organozinc and organocopper compound. So, these are few areas especially of organometallic in which we perform different synthesis in organochemistry. So, let us move ahead. What is organometallic? Organometallics. Basically, when we talk of organometallic, we refer to compound in which we have a carbon and a metal connectivity. So, those organic compound which have carbon metal linkage or connectivity. For example, we can just, this is metal which is less electronegative than a carbon atom, as we frequently study that metal are electropositive. So, therefore, it acquire partial positive charge and partial negative charge form on a carbon atom. So, this is the main identification of organometallics. So, those compounds in which carbon linked to a metal atom. So, such type of compound are known as organometallic. For example, we have examples such as RMgX, which is linear reagents such as methyl, magnesium, bromide, organolithium, organocopper, and organozinc type of compound. In all these categories further we can also have an example of organosodium as well. So, all these are an example of organometallic compound. In all these compounds we have a carbon metal connectivity. So, if there is a carbon metal connectivity, so such type of organic compound will be regarded as organometallics. We have also a compound like sodium methoxide, which exists in ionic form. So, can we say that sodium methoxide is organometallic compound or not? Again, whenever you classify or distinguish a compound whether it is organometallic or not, so the first important feature is that if there is a carbon metal connectivity, then we can say that the compound is organometallic. But as far as sodium ethoxide is concerned or sodium methoxide is concerned, this is not an organometallic because here the sodium or the metal is linked with oxygen instead of carbon atom. So, sodium methoxide is not an organometallic compound. Why? Because here sodium is linked with oxygen but not carbon atom. But as far as all these examples are concerned, Grignard reagent, alkyl lithium such as organocoppers, organozincs or organosodium compounds. So all these have a carbon metal connectivity, so that's why we can say that these compounds or this series of compounds are organometallic in character. But as far as all those compounds in which there is no carbon metal connectivity, if there is connectivity between a metal and atom other than carbon, so such a compound will not be regarded as organometallic. Next, the important features of organometallic compounds is that it demonstrates a reversal of polarity, which is known as unprolonged reversal of polarity, unprolonged. For example, in earlier cases we have a compound like CH3Br, methyl bromide. Here we have a partial negative charge on the bromide and partial positive charge on carbon atom. These carbon exhibit electrophilic character, and this bromide atom demonstrates nucleophilic character. Why? Because the halogen atom is more electronegative than the carbon atom, so that's why these polarities are developed. But as far as the organometallic compound are concerned, such as this one, the magnesium or metal or metals, whatever metal attached to a carbon atom, these metal are electropositive in character, so their electronegativity is less with respect to a carbon atom. So that's why these acquire partial positive charge and this partial negative charge. Just look at earlier cases. Here the carbon has a partial positive charge or it is electrophilic in character, but in organometallic this carbon atom acquire a partial negative charge or it demonstrates a nucleophilic character. This is an important feature of organometallics in which the carbon atom behave as a nucleophile. Why? Because it is more electronegative and acquire negative charge. On the basis of this negative charge, we can say that the carbon play out a role of a nucleophile. So this is a reversal of polarity, which is an important feature of organometallics compound. As far as organometallic compound are concerned, they can metal can be from S block element such as lithium, sodium, magnesium, or they can be from P block element such as copper, zinc, rhodium, palladium, etc. So we can say that the organometallic compound either comes from a metal from the S block element or they contain metal from the D block or transition metal. Here this is magnesium from S block element, again lithium, copper from transition metal, and zinc from transition metal, and sodium again from S block element. So organometal can be formed by metal either from the S block element or from the transition. Why? Because both group exhibit a metallic character, so that's why both type of atoms or metal participate in formation of organometallics compounds. So now we are going to discuss our first organometallic compound, which is known as Grignard reagent. One important thing which need to be realized before moving to the next topic, and that is that organosodium and organolithium compound are ionic in nature, whereas organomagnesium compound are a bit covalent, more reactive, less reactive like rest of the transition metal or organic metallic compound or transition metal also exhibit a covalent character, and they are less reactive, or their polarity is less as compared to organolithium or sodium compounds. Okay, let us now focus on the next compound, which is